where we uncover what's working and what's breaking on the internet, and why. Outages connected to configuration mishaps were a common theme last year, and we've continued to see incidents like these in 2025. On today's episode, we'll unpack some configuration changes that caused back-to-back outages at Asana in early February, along with recent disruptions that impacted Barclays, ChatGPT, Jira, and Discord, all of which appear to be potentially configuration related. I'm Emily Voss, and I'll be hosting today with the fabulous Mike Hicks, Principal Solutions Analyst at Cisco ThousandEyes. As always, we've included chapters in the episode description below, so you can skip ahead to the sections that are most interesting to you. And if you haven't already, we'd love you to take a moment to give us a follow over at Spotify, Apple Podcasts, or wherever you like to listen. Let's start with those two outages at Asana. Here's Mike to explain what happened.
So there's two outages occurred over a couple of days. So on February the 5th and February the 6th, Asana, which is a cloud-based work management software platform, they experienced these similar outages in terms of they had the same characteristics. So what happened on February the 5th, the users couldn't actually log in or access a service. Now Asana actually reported that they're experiencing a high level of errors on their side, so they could actually see that within their system themselves. And during the post-analysis, they said there was a configuration change that had caused a large increase in server logs. So they had this build-up of server logs there, and this increase in the server logs caused the infrastructure to restart. And this led to this cascading of failure with other servers overloaded. Now, when we actually looked at this from a ThousandEyes perspective, what we could actually see was we could get to the front door. And what we mean by that is we could actually make network connectivity. So if I was actually looking from different regions, I could see this path was able to get to it without any sort of coinciding significant network conditions. So we're talking about loss or high latency, which would indicate I was actually getting there. There's a couple of other things. As then when I actually got to this front door, I could get to the Asana service itself. And then what I was starting to see was I could see part of the page actually loading. So we actually consider the page to have like a number of components on it. What was occurring when this issue was happening was the actual component level would actually drop. Now, what this then resulted in was this the effect of having a reduced page load time. So if you're looking at sort of plainly, if I was looking at for one signal, I would say, looks like things are running much faster. But when you actually go into it, you see there's a number of components sort of missing from there. So this again tells me I can actually start to get to the front door. And the fact I can't load the full number of components within that page tells me that I'm actually sort of starting to have some issues retrieving stuff from the back end. Now, when we talk about the back end, this could be a number of services. This could be the fact that I can't make a call to something, I can't reach it, and this will sort of then manifest itself. The other thing then we actually looked and saw in this was then we started to see some server-side errors, so some 502s and some 503s, which gave us some sort of clue to the fact then, it confirmed in fact that this was a back-end services issue in terms of I was actually seeing sort of this bad gateway, and a bad gateway, which is the HTTP 502, sort of indicates that the server received an invalid response. Now that could be a number of things, right? So this is the standard response coming back from there. And then when we actually started getting into it, we actually started to see these 503s. And the 503s then sort of indicate that we couldn't process it. But the point of these are server-side errors. So it means that my front door or my proxy has actually made the call to the back end. As I said, it's got a response back, which means I either have some connectivity there or it's overloaded, it's busy from that. But the point is, it verifies my network components are going right through there, and I actually can't get something back to render that full page or that application. So the second day on February the 6th, we saw a second outage. Now, there's nothing necessary to suggest that at this point they were connected, besides the fact then again we sort of a notification from Asana, there's another configuration error from there, but it had exactly the same characteristics in terms of we could get to the front door. But then we were seeing these errors in the back end where we're trying to retrieve information. Two errors with the same characteristics occurred on consecutive days. But beyond that, nothing specifically linking them together.
Though in this case, we can't definitively say there's anything linking these incidents together. Sometimes configuration-related outages do come in pairs. Why is that?
Yeah, absolutely. So, as I said, there's nothing specifically we could say to link these two together. beyond they had exactly the same characteristics. So, no network issues, something in the back end there. But what you quite often see, and if you think about the time of year, so we're in sort of early part of 2025, we've just come out of a holiday break. There's things like code freezes go on. So where you don't want to touch anything, sort of do no harm, don't want to break the system over that period there. And then what happens typically as you start to come out, we start seeing an increase in these. People are doing maintenance work, they're pushing new patches, they're updating things. There's this work, not necessarily backlog, but work that starts to take place. Now, if I'm making a configuration change to a system, so I'm actually making an upgrade, making a push. If I think about the multiple components, so I have this complex mesh of distributed architectures, distributed applications, different dependencies that I'm making changes to one component of that. I don't necessarily have the understanding or the vision specifically to see right across, if I make a change here, what does it actually impact downstream, upstream for that point of view. So I can make this change. I'm doing it. Everything looks good. Everything's green on my side. My silo I'm actually looking in. I've pushed a patch to that without understanding what its other consequences are. Now, when it happens, obviously we have this situation where we've identified, or this case the vendor identifies that this configuration change has caused this outage to occur or caused this disruption to occur. They can do a couple of things. They can implement a fix, in which case they'll sort of, we'll make the change on the fly, and then we'll sort of see the system recover, and then we won't see it again. The other thing that can happen is they'll roll that back. Depending on how far they've got into that change, then determines whether they're able to roll it back. Because some of these situations, might have actually started to do a push, and it's actually started to have this incremental rollout. It's too hard to roll it back. So in that case, they put some sort of mitigation service in, they bypass it. In the case where they've rolled it back, or in both cases actually, they still have to implement that change, or they still have to put that configuration in, or remove that temporary fix and put a permanent fix in place. So then what happens is, and this is why we're talking about this day later, I'll actually implement this change again, and I might have a similar characteristics, or I might actually have something else that I've actually caused. I've kicked the can down the road a little bit further, and I've actually made I've highlighted another aggregated or single point of failure within that delivery chain. But this is what happens. Now, you can see these occur in sort of pairs, sometimes in threes, and sometimes what we'll actually see is we will see the output from this. So you'll start to see, okay, this change has been made. We've seen a path change. We've seen a temporary glitch in the system, but it hasn't been user impacting. But the point is you have this evidence, these footprints, the change that sort of goes on. Now, obviously, the second time around, or the third time around, they're actually looking for these particular problems, which means that sometimes the disruption isn't actually as long. So they're saying, we think we've actually resolved this. We know we can put what caused this configuration issue in the first place to have this, to manifest as this outage, is that we're going to watch this space. We think we fixed it, but they can actually then, they're more vigilant, which means that outage may be shorter in duration, like disruption may be shorter in duration, because they go, okay, here it is actually going wrong. And in that second time, also what sometimes you see is that if a situation where we've rolled something out and we can't roll it back quick enough, is that they catch it earlier, right? Because again, they're watching for those trouble spots. They're saying, right, we're going to do this push. Okay, we're having the same issue, or we're having a similar issue. Let's roll it back, and they can stop and do it quicker, which means that disruption's slower. So yes, you'll see them in pairs, and you may not see the same duration of outages. And it may just be that these are sort of breadcrumbs or footprints that show that this change has been made, but don't become user impacting.
And tell us more about strategies that ITOps teams can use to guard against disruptions or outages when making configuration changes.
So the first thing I'll say about this is that all these tests have unit tests associated to them. All these configuration changes have unit tests. So each of these groups are actually making these changes. But as I said, you have this complex mesh of interacting dependencies and services and protocols and networks that sort of need to all operate seamlessly together. And it's impractical to be able to understand every particular scenario that can take place. I can actually build in some sort of redundancy, and I can build in these different dependencies, these different playbooks that if something happens, do this and roll this back and stop this. But as I said, it's without all these moving parts, essentially, it's really hard to understand what goes on. So the first thing from this is to get a holistic perspective of that service delivery chain. So what are my components involved? Where are my dependencies going to be? And what this also starts to do is to help you essentially set a baseline or a state of normal. So I can understand what's here, but also what components are involved in here. It can also lead to this understanding of where do I have this potential bottleneck? Everything's going through this single authentication point here. It may be that we want to replicate that system there or have some way around it. Now, you might not be able to do that. It might be that we don't have the capability to actually replicate that. So what you then do is you're going to build in a playbook. If we see an issue occurring here, we see a bottleneck here, this is what we do to instigate that. But the key to all of this is like, if I can get this perspective of my service delivery chain, understand what it is. And when we talk about service, we're talking about the service as it would be for the end user. So, when we hit a system, we don't know, we don't care what protocol's underneath it, we don't care what we are, we just want that particular service to come back from us. And that may include all these areas there. So if I can look at that as a whole, then it's far easier for me to actually pick out where these fault domains are going to be. And then this is the situation, right? I'm looking at that from a holistic perspective. I can start to see that this part's gone red, and then we can actually expedite this time, or we can implement to recovery, or we can implement this rollback, or whatever it happens to be. You can make an informed decision of the steps you take.
On February 5th, we also saw a disruption at OpenAI's ChatGPT. Can you tell us what happened there, Mike, and what you think might be behind this incident?
Yeah, so this was, when we talk about this was a disruption essentially to ChatGPT. Now, it appeared to primarily affect the developers and business. And I say that's because where they actually integrated ChatGPT into their applications. So the point is we're looking effectively at the API itself. So the way we're actually integrating that, making the calls to the back end there. Now, OpenAI have not officially confirmed the incident's cause, but the nature of disruption sort of indicated these issues were within the back end there. And I say that because, again, we actually could see this connectivity to the front end. But when we actually looked at some of the calls that were being made into the back end services, so we're actually not just knocking on the front door, so we're verifying the network connectivity, we can see coming into the service there, and then we're specifically making an API call. What we saw at that point, we didn't actually see sort of a complete break. So again, we're actually getting into that area there. But what we saw was an increase in the wait times and the processing times as we made these API calls. So in some cases, it's kind of doubled. So the point is I'm actually getting to the service. I'm therefore making a call into the back end itself. Now, as I said, we don't specifically know what caused this, and when we're recording this, OpenAI haven't actually come out and said this is what's happening there. But the event did occur shortly after OpenAI introduced this new deep research capability in ChatGPT, and they also launched an education-specific version itself. Now, as I said, we have no correlating evidence to say this is what caused it, but we're making changes to the back end. We're constantly tweaking these environments. And again, when we think about the architecture behind ChatGPT, it is this vast distributed architecture, making lots of calls, a lot of processing taking place. So if we have this vast mesh of environments, any one sort of change or tweak to that environment could potentially have some sort of impact to that. And again, in this situation, remember, we actually saw disruption. So we saw some of them timing out, but it was really sort of a slow, a lagging increase in errors that occurred. So it wasn't that this system was necessarily unavailable. It was just got to the point where it actually couldn't be used. I'd make a call and it would fail because it would actually time out, or it would just be really slow in coming back in response. So people might have actually aborted, or the application itself would have had some sort of timer in it. So we're looking at that point there.
We can't definitively say that ChatGPT's disruption in this case was due to work or updates from OpenAI, but we do recognize that such changes can potentially cause incidents like this. Mike, tell us more about the characteristics of disruptions caused by updates or configuration changes. What should teams look for when diagnosing an issue?
It's a good question. And again, we're coming back to this aspect of let's look at the multiple signals. So we know the network is good. We can get there. We can get to the front door. And also, we're not just looking at one path. If I can look at multiple paths, I'm coming from Australia into my local area, or I'm going from California and coming into to where that local server is there. I'm looking from two different regions. So the chances of me having a global network issue across multiple providers, is quite rare. Doesn't say it doesn't happen. And again, if I'm looking at this, I might come into a common aggregating point, or it may be that there's some sort of the way that service is being advertised across the environment has been withdrawn. But again, I would see that at this common aggregating point. So the fact that I'm actually getting into the system, remember this was slow and increase of errors as opposed to a complete outage. So again, I'm going, could be slow because I have latency, but I've proved that from the network perspective. So now I start looking into that back-end system. And now I'm going, well, what type of errors I'm actually seeing there? So in this case, it was slow. It was starting to sort of an increase in errors on their side, but I'm actually seeing this increase in processing time, increase in overall response time. So I'm saying, well, I'm actually taking a while to get through from there. It's not that I can't get to the system in the back end and make these queries. It's the fact that it's actually slow. So I'm looking for the combine these signals. So I know the network's good. I know I can get to the front door. I know I can actually make this request. And now I'm starting to go slow in the back end there. So then I'm looking to identify, okay, what's changed in that environment. Now, depending if I've actually got this hosted in a cloud environment and I'm an enterprise organization, I could actually see, all right, has there been a change made to the infrastructure? I could actually say, right, have we changed some sort of security group policy, for example, that suddenly made that performance there? Because I've got performance good up to this point, it's this point that's slow. So I actually can see that and start to do that. I'm looking at these little markers, but I can also do it from exception reporting. If I'm looking from a SaaS type of application that I don't have control or access over, I can actually say, again, I'm up to the front door. Beyond that, I'm actually started seeing this slow. Now, do I get some sort of error coming back? So a 502, a 503. What point in that workflow do I actually see that error occurring? Because that tells me, am I failing on authentication? Am I failing on making the query or something else from there? Or am I failing actually pushing something if I'm looking at the API? So I can then start to diagnose what's going on from that one there. So what I've done now is I've identified the fault domain. The next point to that is then, how do I know that's a configuration change? Well, I don't really. Yeah, again, if I own that application, if I look and I own that application and I've hosted it in a cloud environment, then absolutely I can actually look and I can look at some of the things like the event logs to understand, has a configuration change been made? And I can actually look at it in the context of what's going on for my particular environment. If I don't own that, then again, I could possibly go to their status page and see what's happening. But it may or may not show that something was going on from that place. As we saw in the case of Asana and actually OpenAI, they both had in their status page that they acknowledged that the error was on their side and they were doing it. So again, I know what's happening at that point. But coming back to if I own the application, I don't necessarily know a change has been done because it's not all the stakeholders don't necessarily need to be told what's going on because we might not know they're a stakeholder. So what I can do is basically identify that fault domain. So I can go through proactively, I can identify this is where that fault domain actually lies. This is where it is based on those signals we just talked about. And then I know what to do. I either need to escalate it to that particular group or I need to take mitigating action. Or if it happens to be something within my area, in my control, I can roll it back. It may even be, for example, let's say we do have this network issue, configuration's changed for the network services. And what I've done is I've actually changed the prefix to how my network's advertised from a BGP perspective. So therefore then what I can do is actually roll that back and change and advertise myself out of a different network, for example. So identifying the particular area by understanding that holistic perspective, my service delivery chain allows me to either take mitigating action or take steps to come around it. The clues are going to be in those signals. So I can actually then break that down to identify what's going on. And I can't ever definitively say unless the vendor tells me or someone tells me it's a configuration change, or I can see it within my event logs, for example, from the cloud provider. But what I can do is say, this is a fault domain. This is the most probable cause of the issue. This is the element I either need to work around or take steps to roll back.
And now for a quick roundup of other incidents we've seen recently. On January 31st, Barclays customers experienced an outage that may also have been connected to service updates. Explain what you saw there, Mike.
So this was the outage that actually occurred within the application itself. So this was an error with payments and transfers as reported by Barclays. So this was actually impacting then the actual services itself. So people could actually get onto online banking, they could get into the system itself, but then they couldn't transfer money. They couldn't actually sort of check accounts. There was some of these back-end services that were going on. And obviously they couldn't make payments coming out from there. Now, that tells us a couple of things. So again, we're looking at what is or what isn't happening with that environment itself. So we're saying, right, this is very specific to Barclays. We could actually see what's happening within the, it's impacting the application, and there's no commonality. If I think of a fintech service or financial services, they will have some shared services. So if I'm coming out to pay another bank, I might use some sort of a payment gateway or some transfer system or some network to do that. If there was an issue within that, it would have impacted different financial organizations. So I'm doing this isolation because, again, we're talking about an application here that we don't own. So this is something that's within that environment. So what I'm looking for is signals. I can see to the front door, I can get into that system, I can even log on to this system. It's when you then try to interact with it. Now, unless you want to do some sort of destructive test where you're trying to go through, you can see that. But again, you can't take any action on that because it's beyond my control. All I'm doing is confirming that, yes, there's an issue in this back end. Again, what you do is that's that mitigation. But what I can do is it allows me then to identify that the problem isn't with me or where that specific area of the fault actually lies. Now, we've said in this one that there is no direct correlation specifically to what's happening. But again, with all these systems, again, we're thinking about the time of year, we're coming up and we're starting to make changes to environments, we're tuning this system. And if you think about all applications out there, just imagine how many times a day you actually get asked to upgrade your browser, for example, or upgrade your PDF reader. These pushes and changes happen all the time. So again, if I talk about this interactive system where I have all these components there, these changes can occur at any time. But again, I'm isolating specifically where it is, where that fault domain lies, and then you can actually take the appropriate action.
On February 5th, users of Atlassian's Jira experienced an outage that rendered the platform slow or inaccessible. What seemed to be going on there, Mike?
So this actually seemed to be intermittent errors where the user could actually get through. And again, Atlassian acknowledged they identified the root cause and they sort of mitigate the problem. But they did actually know, or we did sort of see intermittent errors coming into the next day. Now, this outage sort of followed a similar incident on February the 3rd. Where again indications point to back-end services. Now there's no direct correlation between the two, but again we come back to these signals. We had intermittent issues, it was a slow system, you could get to the front door, you get to service, but you couldn't execute specific functions within that system. So I'm isolating parts of that problem, that fault domain. I'm coming out and saying I can get to it, I can log on, I can authenticate, I can't execute. And in some cases, error systems come back. If I'm looking for that, error messages that come back. But I'm identifying down where that particular fault lies.
And to conclude our outage roundup, let's take a look at a recent Discord outage. On February 4th, Discord users had issues sending and receiving messages, although they could still connect to the platform. What did you see there?
So again, coming back to this identifying the signals, what we could actually see was we could see connectivity from all regions around the globe. You can actually get into the system. So again, I'm authenticating to the system. I can actually get that page. I can load the page up, and in some cases, then you can actually sort of get the refreshes to see what's happening there, or and as we said, the messages couldn't be sent. So again, I'm actually looking specifically at this is a back end system. So I'm actually identifying that I can't see. That I can reach the front door. I can reach the front door from wherever I am in the world. So therefore, I'm not looking at this common network problem. I'm not looking at, say, a routing issue, for example, from advertising my network. I'm not looking at a name resolution problem. I'm looking at a service issue. I can get into the system. I just can't get that. That's sort of what we call like a functional failure, where one particular function within the application or the service is not available. So for all intents and purposes, everything's up and working, but we actually can't get to it. So again, they identified the problem and they actually sort of did the rollback to fix that. But when we're looking at this, we're looking from this common aggregating problem to understand specifically where that issue actually lies. And in this case, it came within the application or within the back-end services.
Thanks for the insights on those outages, Mike. And now let's take a look at the overall outage trends we've been seeing over the last few weeks. What have you noticed?
As we came into the new year, we've started to see this increase in outages. So again, we talk about specifically this, we've come out of a code freeze, we've come out of a holiday period. Now remember, we're talking about effectively network outages here. So we're looking at the providers, the ISPs, the CSPs, and sort of the work they're going to do. Now, we started to see this rise coming up. We saw this upward trend occurring from the start of the year, as we sort of expect. Then we started to see at the beginning of this period sort of a little bit of a drop, so it actually dipped down. It actually went down just higher than we've sort of seen, so we're still seeing a significant number of outages. But again, now that we start to see coming out of this, we start to see this rise. Now, when we actually look at what these outages are, we're looking from a time of day perspective, and we're also looking from a regional perspective. So we started to see these changes taking place. They all occur outside of business hours to local area. They also tend to be a little bit contained, and they sort of occur, so it's the middle of the night, and then we can see this pattern evolving of where they're actually sort of the outage is impacting. So when I say that is when we actually look at these outages, we see this number rising. In a number of these cases, they're not particularly user impacting, or they didn't appear to be user impacting, because we're understanding what we're doing before they make this change. They're making or to carry out this maintenance or this upgrade work. The organisations are actually sort of taking steps to reroute traffic to sort of mitigate there. And obviously on top of that as well, we're dealing with the internet, which is incredibly resilient architecture, and it was designed to route around things around there. And the fact then that they can actually keep these outages or the disruption fairly localized to where they're doing their work also aids that system, because it's easier to sort of route around it.
Great overview, Mike. And now take us deeper into those outage numbers you've been seeing. So
this time we're actually looking at a 3-week period. So looking from January 27th through to February 16th. So I said they actually dropped to start with. Talk about global outage here. So after an initial drop, we sort of saw this upward trend. So in the first week, January 27th to February 2nd, we saw a 16% decrease. That was that drop where I saw it come down, but we still saw that maintained level. So we dropped from 395 to 331. Now, the following week, February 3rd to 9th, we actually saw this reversal where we started to see the outages coming back up. So they went from 331 to 353. And this is a 7% rise where we compare that to the previous week. And then we continued into the third week, so February 10th to 16th. We saw the outages rising from 353 to 398, which is a 13% increase. Now, in contrast, the US, we observed a slightly different pattern. So initially we saw these outages decrease, as we saw from the global outages. So we saw 195 to 188, which was a 4% drop where we compared to previous week. Now in the second week, which is February 3rd to 9th, the outages actually increased by to 12%, which is then followed by a 7% decrease from February 10th to 16th, where the numbers actually sort of fell from 210 to 196. So this was a slightly different pattern, but it remained sort of more stable, if you like. So we're still up from where we came from the start of January, but over this period, we didn't potentially follow the global outages. Now, there's kind of different reasons for that. If we actually look into where they're occurring, again, we're sort of seeing work being done, particularly in sort of the EMEA region. So we're seeing some of these, again, talking about this local time of day where we started to see the outages occurring at 2 and 3 in the morning from a local time perspective. And again, this localized aspect, so it didn't sort of flow down effectively into US area. Now, having said that, if we actually look at sort of the January 27th to February 16th, what we actually saw was 55% of all network outages being US-centric. It means they occurred in the US infrastructure themselves. And this is an increase on the 49%, which we saw from the previous period, which was that January 13th to 26th. Now, this 55% figure is kind of interesting. This is a trend we observed right through 2024, where the US-centric outages accounted for at least 40% of all observed outages. And it sort of looks like this trend's going up. So we actually come back in the previous years. So 2023, we sort of saw it below that 40%. 2024, we saw it higher. We saw it over the 40%. But now this is the start of the years where we start to see it coming over 50%. So, or at least 50% and higher, where we start to see these outages. Now, what that tells us really is that, again, we have obviously infrastructure within the US. We're actually looking at infrastructure there. We start to see these outages, but they're not necessarily then flowing on into the global one. So this is what I'm talking about, this localized outage. So if I actually can control my blast radius, as it were, while making this change or doing my maintenance work, what this then means is that I'm not having this domino effect. So if we go back in time, when we actually started to make a change, we take some interface down, we'll make some change to a line card, or we change some optical card within a system there, and it had this domino effect. I take point A down and point B will go down, which might be the other side of the world. But now if I could control that either through software or through premeditated steps where I sort of mitigate around that, I've changed my routing to start with there, then what I'm actually going to do is going to contain that interface. So I'm going to contain that outage to this local area, which is why we see this rise. So why they account for this number of outages going forward. But it'll be interesting to see how this continues throughout in 2025.
And that's our show. Please give us a follow and leave us a review on your favorite podcast platform. We really appreciate it, and not only does this ensure you're in the know when a new episode's published, it also helps us to shape the show for you. Follow us on LinkedIn or X at ThousandEyes, or send questions and feedback to internetreport@thousandeyes.com. Until next time, goodbye.